In this video, we are going to prove that a given expression is irrational. Okay, so the question reads, if the root of 2 and the root of 3 are irrational, prove that 3 root of 3 plus 2 root of 2 is irrational. So we are going to prove this by contradiction. Okay, so in this contradiction method, we are going to assume the opposite of what we want to prove, and then that will help us come up with our proof. So we are going to say assume, okay, assume that 3 root of 3 plus 2 root of 2 is irrational. Then there exists, okay, then there exists two integers, okay, two integers a and b, such that a over b, okay, has no common factors and b is not equal to what? To 0. So this a over b having no common factors simply means that we do not have a single value that can go into a and can also go into b without leaving a what? A remainder. Okay, so it means this a and b are in their what? Lowest terms. So this is the first assumption that you always make when you are proving if a certain number is what? Irrational. So after we write out this, and then we can start our proof. Okay, so let's start our proof now. So always write that expression on top before you start. So now we are going to say, by our assumption, 3 root of 3 plus 2 root of 2 can be in the form what? A over b, where b can never be equals to 0 and a and b are in their lowest terms. Okay, and then from here, what we want to do is, okay, just make sure that one of these roots is on the left side alone, and then the other expressions or the other numbers in this expression here are on the right side. Okay, so as long as you are able to do that, then we would have completed our what? Our proof. So what I'm going to do here is this. Okay, I'm going to say 3 root of 3 is equals to a over b minus 2 root of 2. Okay, and then from here I'm going to subtract what I have on the right. So here I still have 3 root of 3 is equals to, okay, here I'm going to write common denominator is b. So b into b is 1, so here I have a minus, okay, 1 into b it's b, so here I'm going to have 2b root of what? 2. And then from here we can cross multiply. Okay, from there we can cross multiply. So what we are going to have is this. So we are going to have 3b root of 3 is equals to a minus 2b root of 2. So that is what I have there. Okay, and then from here we are going to square both sides. So you square this side and you also what? Square this side. So when you square this side, you're going to have what? 9b squared and then 3 is equals to, so here we are multiplying this a minus 2b root of 2 by itself. So it means a multiplied by a, we are going to have a squared. A multiplied by 2b root of 2, we're going to have minus 2ab root of 2. Okay, so we are done with the a, and then now we multiply by this. So this guy here, the 2b root of 2 multiplied by a, we are going to have minus 2ab root of 2, and then the minus 2b root of 2 multiplied by itself. Okay, so I don't have space here, I'm going to say plus, we're going to have 4b squared and then 2 in the brackets like that. Okay, so that's what we have. So meaning here I will have a 27b squared is equals to a squared, and then in the middle here these are the same things, so it's going to be minus 4ab root of 2 and then plus 8b squared. Okay, so that is what I have there. So we see that in this expression we now have one root. Okay, we only have this root of 2. So to complete our proof, we just want to take this root of 2 to the left, and then whatever remains we take it to the right. Okay, so let's create some space here. Okay, so this is what we are going to do. Okay, so we are going to say this minus 4ab root of 2, I'm going to take it to the left hand side, so it becomes positive 4ab root of 2, and then this is equals to, okay, this 27b squared goes to the right like that. So to the right we have what? A squared plus 8b squared, and then when this goes to the right it becomes a minus 27b squared. So this is what we have here. Okay, this is what we have. Okay, so from here we're just going to divide both sides by 4ab. Even this side we divide it by 4ab. So what we are going to get is that root of 2 is equals to a squared plus 8b squared minus 27b squared divided by what? 4ab. So this expression now that we have here will give us the contradiction that we want. Okay, so this expression here is going to give us the contradiction that we want. Okay, so from that expression that I've put in a white box there, we see the contradiction. So we are going to have the left hand side, which is the root of 2, okay, and we know that the root of 2 is what? Irrational. We've been told in the question. And then what we have on the right hand side, okay, is a squared plus 8b squared minus 2b 27b squared, I mean, okay, and then we are dividing by 4ab. So this here is what? A rational number. So if you want, you can combine this 8b squared and the minus 27b squared. So let's combine. So we're saying right hand side is equals to a squared, and then when we combine that, what do you get? Okay, we get minus 19. So minus 19b squared, and then divided by what? 4ab. So this minus 19 a squared minus 19b squared over 4ab is what? Rational. So why is it rational? Because we have integers in this expression. A is an integer, b is an integer, a is an integer, b is an integer. Okay, so when you divide an integer by an integer, you get a what? An integer, and we know that an integer is a rational number. So we have on the left hand side we have root of 2, which is what? Irrational. And then on the right hand side we have this expression here, which has simplified to this, which is what? Rational. Okay, so it means our right hand side, okay, our right hand side is not equal to the left hand side. Okay, so it means that our left hand side is not equal to the right hand side. Okay, hence by contradiction, okay, hence by contradiction 3 root of 3 plus 2 root of 2 is what? Irrational. So we have proved. Okay, so now you know how to prove that this expression here is irrational. So that's all for this video. Please like, subscribe, and share the video with your friends. Okay.